Okay, here we go. So anyway, if you plug in those numbers into this function, it's a little hard to tell, but this is e raised to the x power. So if you have e raised to the x, and the same pattern holds if you had something like e to the 2x, e to the x squared, e to the x cubed. If you take an x and you plug into any of these functions and you let that x get larger and larger and larger, the value you get grows very quickly. E to the 100 power is a number that is 43 digits in length. That's what it means when it has the plus 43 on the end. So it only takes e to the 100 power before you have a number that's 43 digits long. Okay? So what you're memorizing is, if I have what's known as an exponential function, and I plug in larger and larger values of x, that is going to grow unbelievably fast. Compare that to this one, x squared or x cubed. Notice, x cubed with a 100 plugged in is 1 million. That's not very large compared to a number that has 43 digits. Questions? So you have to memorize that comparison. If you're plugging in larger and larger values of x, exponential functions of this type are going to get large very rapidly. This one you got to be a little careful. This will vary. This one will be affected by the negative. The others are affected by the negative as well. If we plug in negative numbers, these three here, they're all going to get very close to 0 very fast. So plugging in a negative 100 as x, you get a number that is like point, and then like 44 zeros, and then finally some numbers. That's how small that number is when you're plugging an x into this. So you need to memorize that pattern. That's going to be needed to solve the problems on the yellow as well as possible problem on the AP test once in a while. Questions? Okay, we already talked about power functions. They always become large positive or large negative. It doesn't really matter. Like if you're comparing x cubed to x squared and you're plugging in a large negative x, the x cubed still dominates. That's what you used in the homework last night, the pink packet. So, questions about anything? The last one to look at is right here, ln functions. So natural log of x, that grows really slowly. So notice when x is 100, e to the x is already a number 43 digits in length. X cubed is only 6 digits in length, so much smaller by comparison. The natural log of 100 is 4.6. So it grows very, very slowly by comparison. And then the natural log, you learned this in another class, the natural log of any number that is 0 or negative isn't even defined. So you don't memorize this chart, but you memorize the idea, and then we're going to use it on the yellow packet. Questions so far? Cool. Let's do number 1. So number 1 is a limit as x approaching infinity. The instructions for the yellow are the same as they were for the pink. You're going to find the limit as specified, but you're also going to find if there are horizontal asymptotes or not. So we just do the same thinking process. We have x approaching infinity. We want to compare terms that add. So raise your hand if you can tell me what the terms are. Well, you guys know. The terms in the numerator are 2x and a positive 8x raised to the 2x. So what I just showed you on the chart is both of those will grow, but the exponential will grow much, much faster than the power function. And so the dominant term of the numerator is the exponential. So we're going to say equal here. Limit x approaching infinity, 8e to the 2x. Making a similar comparison on the bottom, we're going to get 2e to the 2x. Questions? Do the same thing we did last time. We break it into factors. This green step can be done in your head. It is not required to be written down. Raise your hand, please, if you can tell me. This is a bit of a trick question. I'm curious how many can get the trick. What is the value of the green box? There we go. Let's go, Caleb. 1. How many agree? 0.2 for Caleb. The green box has a value of 1. I will often ask, is there any exceptions to that? And a common exception is to say, well, if the green box becomes 0 over 0, then the green box is undefined. But when you have an exponential function, there is no possible way for the exponential function of that type to ever equal 0. So this will equal 1 for all x, including x equals 0. Questions about that? Cool. So now we know as x gets bigger and bigger and bigger, 4 times 1 is 4. So this limit is just 4. Which means we've studied half of the asymptotic behavior, because we know that as x approaches infinity, y is going to approach 4.
If you write, at least last time, if you write x squared as like x over x and then x over x again, is e to the second x 1/3? Because like e squared, it's not that.
So tell me what
Like,
you want to write down.
If it's x squared and then like we break it into the multiplication, you go like that, and it just goes 1, right?
That would. This one's different though, because 8e to the 2x. So forgetting the a, e to the 2x, that's not the same thing as like e squared, which would just be e times e. I'm not sure I really want to break that. Like I can rewrite this like this.
It's easier just to keep it 1 though.
Yeah, that one's not helpful to change, to be honest.
Okay.
Does that help a little?
Yeah.
2 more.
Yeah, that one changes.
Hey, the other questions here. Okay, warning, look at me. Everybody look. Look. Okay, here's how the AP test writers will trick a lot of students into picking the wrong answer. They get this far and then they forget that they need to check what's happening as x approaches negative infinity, and things change when you're dealing with exponential and logarithms. With power functions, you probably got into the habit on the pink packet of like noticing that nothing was different whether we were having x approach positive infinity or negative. That's fair with a power function. With an exponential, it's not true. So you should draw a line on your paper to indicate that you're going to do a little different thinking now. So now we're going to find the limit as x approaches negative infinity. Two x plus 8e to the 2x divided by 2e to the 2x plus 4. Okay, we still want to compare terms that add, because we do have a limit as x is approaching negative infinity. But now we have to remember the chart I just showed you. So look here, we're comparing, what is it? 2x and 8e to the 2x. So we're comparing 2x and 8e to the 2x. This is going to behave pretty much like this. As x approaches negative infinity, because the 8 doesn't really matter, e to the 2x is going to behave very much like e to the x because we don't have anything that's going to change a positive to a negative or anything. So we notice that as x gets larger and larger negatively, this is going to shrink very rapidly. It's going to become extremely close to 0 really fast. Questions? Okay, that's being added to 2x. Well, 2x is going to become extremely negative quickly. So raise your hand. As x approaches negative infinity, which one dominates? You're adding them together. Which one is way more important than the other when you add them? This one here, raise your hand please. This one's going to become very, very close to 0. This one's going to become extremely negative, like a large negative value. You take a large negative value, you add it to something that's very close to 0. Which of the two is important when you're doing this arithmetic? If your hand is raised, you're giving yourself 2. We're going to go to Sam Hartman. What do you say?
2x.
The 2x dominates. 2 more for Sam. So the next line should say, this is equal to the limit as x approaches infinity, negative. We only need to concern ourselves with the 2x, not the 8e to the 2x. We want to talk more about that. Okay, look at the bottom. Raise your hand if you can tell me which of those two terms will be dominant. There we go, George.
Would it be the 2e, 2x?
2 points. Let's talk about it. Let's make sure. So we have 2e to the 2x. So I'm going to give you some more points here, George. Help me. So 2e to the 2x. Well, what I'm looking at is like, okay, it's not e to the x, but pretty similar. So as x gets increasingly negative, this will become a number that is unbelievably close to 0. We're going to be adding that to a 4. So when those two are added, which becomes most important as far as the final answer? The 4 or the number that is unbelievably close to 0? When you add them together.
Are you saying which one will be smaller?
No, I'm saying that badly. I'm saying that's my fault. If you have 4, we're going to add that to something like this.
Yeah.
What's the result very close to equaling?
Like 4.0, 4 point, yeah.
Yeah, it's perfect. Very close to 4. So what you just said in a different way is the 4 is far more important
Yeah.
than the other term. So the term on the bottom that dominates is actually the 4. 2 more for George. Did that make sense? Questions? Someone want me to talk about that again in a different way? Okay, we got that far. Now we just say, okay, not too bad now, because as x approaches negative infinity, we're going to have 2 over 4 multiplied by x over 1. So this is going to become extremely negative, so the whole thing is going to become extremely negative. Now we have a conclusion. There is a right hand, or right half, horizontal asymptote at y equal 4. But there is no left half horizontal asymptote. Questions? Please.
We go straight from the blue to x over 4 to the equals negative infinity.
For sure. Yeah, the green is just me tending to make sure we're really clear.
So as x approaches negative infinity, y approaches negative infinity.
Correct. Which means if you're thinking of a graph, 2 for Trey, 2 for Jackson, you're going to see some sort of trend like this. I don't know the shape, I just know the trend. It's going to go like that. Rock.
Where'd you get the negative infinity from again? I'm just gonna...
You're okay. Are you comfortable with our step here where we're comparing terms that add?
Yes.
So are you comfortable with this statement here? Awesome. then all I did was basically just kind of mentally think about, okay, what am I going to have here? So what's this equal to, Brock? Will that value change based on the fact that x is getting more and more negative, or will it remain the same?
Just remain the same.
Just always 1/2. This will change though, because we are plugging in for x, whatever x is, and this whole thing here is computing a y value. So we're finding that as x becomes very, very negative, we take whatever that negative is, like negative 1,000,000. We multiply it by 1/2, we get negative 500,000. We plugged in a negative trillion, multiply it by 1/2, we get negative 500 billion. So as the x value becomes increasingly negative, the y value does as well. 2 more. Other anything. Cool. Stop the video.